All right, so we're talking about integrals, and today we're talking about multiple integrals and how we find areas between curves. And what I just want to start out with is an expression. If I say the integral from 2 to 3 of fx dx, I just want to remind you that this is not a function. I know there's a lot of things in there that look like variables, and it looks like something that might be able to take on multiple values, but this is not a function. This is a single value. And what it equals is if I take, what's a function, let's use y is equal to the square root of x, and I go from 2 on the x-axis to 3 on the y-axis. What it equals is, well, it equals, one way to think of it is it equals this whole area here. But it's also kind of like an operation. And what the operator does to get that area is it slices this area up into tiny little, much tinier than I'm making right here, but tiny little slices, and it sums them all up, and the slices are infinitesimally thin, and there's infinitely many of them, and you end up coming away with an area, not just an estimate of the area, the exact area of this amount right here. And so now what's relevant to think today is what happens. Let's say I have this function, y is equal to the square root of x. Actually, let's call it f of x. And let's say I add another function in there. And I'm going to call this g of x is equal to 0.1 x squared. And let's say I just pick a point, and I say when x is 3.5, I want to know what this height is. Okay? And so I think a lot of you can realize that to find the height, that f of x is going to be above just the x-axis. It would be square root of 3.5. And then if I wanted, then I would need to subtract out the area that the lower curve is above the y-axis, which is minus 0.1 x squared. Sorry, not x squared, 3.5 squared. So that would be how I'd find the height if I wanted just one slice. But guess what? I want the whole area between these two curves. And this is a typical AP type problem where you're given two curves and you're asked to find the area between them. And notice that there's a piece of information that I left for you guys to infer, which is what are the boundaries of this space? Okay, so what hopefully you can see by looking at this is this area that I want right here, that I'll call A, I could write as, let's call this A, and let's call this B right here. I could write this as the integral from A to B of f of x minus g of x dx. Only thing is, I need to figure out, well, this looks like it's 0, and I can kind of look at the functions and recognize that that's going to be 0. This part, I don't know what that is. So I could go and find that out on Desmos. Or I'm going to start using the calculator for this one. Okay, so I'm going to plug these in, and I'm going to say this is square root of x, and y2 is 0.1 x squared. And I'm going to pick zoom, I don't know, decimal. Let's see if that works for me. Okay, it looks like it works. And then I'm going to try to calculate the intersection point. By going here, and I get x is equal to 4.642. I guess I'll round to three decimal places because that's what the AP test wants me to do. So this is like the integral from 0 to 4.642 of, now I have to figure out which one is on top, which is the square root of x, and I have to figure out which one is on bottom, minus 0.1 x squared dx. And I can actually evaluate this on my calculator too by going math and finint, and it's going to go from 0 to 4.642, and then you can go vars and y vars and function, and I want y1 minus y2 dx. I think that's how I have them in here, right? y1 minus y2. And then I hit enter. And then I have my function. It looks like 3 1/3. All right, so let's take another one. Let's do one more example. Oh, here's a good example. Let's say I have a function like this. This is the square root of x. And then this is negative square root of x. Okay? Let's say if I wanted where x is equal to 2. Let's make x equal to 4. And I wanted to know the area, the distance between the two curves. What would I do? Would I take square root of x, and because it's negative, because the other one is below the x-axis, would I now add it plus negative square root of x? Well, notice if I did that, I would get 0, right? And if I took what we know, I picked 4 because we know the value here. Would it be 2 plus negative 2? No. Would it be 2 plus 2? Yes. But technically, what the answer would be 2 minus negative 2. So I'm showing you this to show you that it doesn't change. When we're finding the area between the curves, we subtract. You don't have to adjust for the fact that it's above or below the x-axis, because if it's below the x-axis, it'll give a negative number, and that's in essence already doing that for you. So all you have to figure out is which function is on top and which function is on bottom. So I'm going to give you two more functions now. Y is equal to x squared minus 2x plus 1, and y is equal to 2x minus 2. And I want you to calculate the area between the curves of those functions for me. So let's say, and when I say I want you to do it, in a perfect world you would, and we'd have time, and I could give you a second to stop and do this. But we're not in such world right now, so I'm just going to do it for you, and you're going to hopefully watch. Whew. Okay, so this is what my function looks like. You can see what it's starting to look like. Let's see, I'm going to go from 0 to 5. And let's go from negative 0.1 to 3.5 maybe. Okay, and so we want this area here between the two curves. So the second intersection point is at 3, 4. And the first intersection point is at 1, 0. So the integral that I could set up would be integral from 1 to 3 of, which one was on top? 2x minus 2 minus x squared minus 2x plus 1 dx. But what I want to show you is, and I'm going to use Desmos to help me for this, is y is equal to so I can calculate that integral by saying integral from 1 to 3 of g of x minus f of x dx and I get 1 1/3. But what I want to show you is that there's another way to calculate it that should give me the same values if I can do it. In some functions you can do this, in some functions you can't. But if I'm taking a function and what the way the integral that I wrote is going to do is going to go through and make vertical rectangles. But there is another way that I can go back, and if I can make, instead of vertical rectangles, I can make horizontal rectangles, then it's possible to find this integral in another way. And for some examples, it'll actually be easier. But what you would have to do, so y is equal to 2x minus 2. I would have to change this, y plus 2 divided by 2 is equal to x. Okay, and then the other function I don't think is invertible. Y is equal to x squared minus 2x plus 1. This function is not one that I can invert. So I guess I picked a bad example to show you of this. Let's see. Well, let's go back to let's go with the original functions that I had. What was it? Y is equal to square root of x and g of x is equal to 0.1 x squared. And I had the integral from 0 to 4.642 of f of x minus g of x dx. And that's 3.3. So now if I can do this on the fly, this should be the same as when I integrate from, well, we'll figure that part out afterwards. So now if I'm thinking of what is this going to look like when I do horizontal rectangles, well, it's this parabola that's on the outside. Okay, so that's going to be the bigger value. So that's going to be 10, it's going to be square root of 10x minus x squared. And we're going to be going from, so now we have to think of what am I going from 0 up to 2.154. And I got the same thing, almost. But it's off only slightly, but I'll take it. I think that's a acceptable error in this case. It probably has to do with the fact that I'm rounding my boundaries. All right. Thanks for listening.